Hi dear students, so in our last classes we were handling the integrated rate equation, that is for zeroth order we have seen, first order we have seen, correct? So today what I am going to extend here is, I will discuss the first order also in terms of, we learned already T half, what is T half life of a reaction. We will just also learn what is 3/4 of a reaction for a first order, and also I will give you an integrated rate equation for nth order, and this equation is applicable for order above 1. That means for order 2 you can apply this, for order 3 you can apply this, but this is not mentioned in your NCERT textbook. Sometimes it can come for exam actually. Okay, so and also this will be useful for JEE students as well. Okay, so let's start with the first order integrated equation for the first order. So as you know, what was the equation I have given there? So for a first order reaction, T is equal to, we know, 2.303 by K log A0, concentration, initial concentration by concentration at a time T. I hope everybody might be knowing this equation, correct? So here one more way we can express this. For example, you can consider reaction where A is getting converted to a product. Why I am saying this also is, in some books you may say in this format also. Now we say at a time T is equal to 0, at a time T equal to 0, and at time T is equal to T second. We don't know what is this instant. So we know initial concentration is A. Let us assume A is the initial concentration. At that moment there is no product, so we can say put 0 actually. Now after a T second, the product formed here is, assume like X is the amount of, or the concentration of the product formed. In that case we know that the concentration will become A minus X, because initially A was present. Out of that some amount of A gets converted to X, then the remaining will be A minus X. So in this case, how will you write the integrated rate equation for first order? So let me write here, this is first order. Okay, first order reaction, very important. Now I can write the same equation as T is equal to 2.303 by K, that is the rate constant K, log, correct, initial concentration A0, here is what actually, A, divided by the final concentration at time T. What is the reactant concentration finally? A minus X. So this is another way in which you can express the equation. So in some books you may see this also. So many students will come and ask this doubt, sir, I didn't understand what is the X or what is A. So please understand, X is the amount of product formed and A minus X is the amount of, the remaining amount of reactants. So you can note down this equation as well. Okay, I hope this equation is also clear for you. Next we will try to discuss what is the time for 3/4. Okay, time for 3/4 of the reaction. T half we discussed, 3/4 also we will discuss. I will tell its relevance. Okay, so let me rub this. I hope everybody have noted down this. Okay, so let's go for that. So meanwhile, I hope every students are doing problems, what and all I have given you in the classroom. Also I told you you could find the problems in our YouTube channel. You can just subscribe the YouTube channel so that you will get the list of problems. You can see the playlist there, you could see chemical kinetics playlist. You can watch and view that videos also. Please subscribe it so that you will get all updates. Okay, it will be helpful for you. Fine. So next heading is time for, you can write there, time for 3/4 of the reaction, 3/4 of the first order reaction. All these I am explaining for first order reaction, for first order reaction. So in bracket we can say T 3/4, time taken for 3/4 of the reaction to complete. So how will you derive this one? We will start with our fundamental formula. From that we can derive this one. So we know that T is equal to 2.303 by K, correct? I can say log A by A minus x. Just now we have seen the formula. Now we assume at time t is equal to t3 by 4. So when time becomes t is equal to t3 by 4, what will happen to the product actually? So how much amount? We know that half-life means the time in which the reactant becomes half of the initial concentration, correct? Now in this case, when 3 by 4th of the time is consumed, so what will happen? You can say 3 by 4 or that much amount of product has formed, correct? So I can say here x, so initially it was A, then concentration was 0. Thereafter we know that 3 by 4th of A has formed, correct? Because 3 by 4th of the time has passed out, correct? So in this case I can say what will be this one, then A minus 3A by 4. So what is this value? That is what you need to substitute in the which part here instead of A minus x. Or we can just substitute x is equal to here, x is equal to what? 3 by 4A. So I can say x is equal to 3 by 4 of A. So t is equal to 2.303 by k log A by A minus 3A by 4, correct? So what does this value will become? A minus 3A by 4. I know that this is A by 4. If you think logically also it is correct. Why? Because 3 by 4th, 75% of the time has passed. So 75% of the product is formed. So the remaining is what? 1 by 4th of the reactant. So that is what? A by 4. So this A and A will get cancelled off. So I can say this is what actually log. This is log 4. Correct? Now this log 4 itself can be written as how? You know that. So this can also be written as 2 square. Correct? So this can be further written as, I can say 2.303 by k into 2 log 2. Correct? Now tell me, if it is, we already know 2.303 by k into log 2. What is that actually? T half of the reaction. We already learned that. Or I can substitute and convince you. Now, so what is log 2 here? So log 2 can be substituted as, I can say log 2 is 0.3 times 2. Okay, so this can be multiplied. So when you multiply 2.303 into 0.3, what will happen there? So I can say this will become 0.693 divided by k into 2. Correct? So this is T3 by 4. So what does that mean? We already know 0.693 divided by k is what actually T half of a first order reaction. So I can substitute, I can now replace this with what actually? T half. So what is the final conclusion of this one? So I can say my final conclusion is very simple. So conclusion is what? Just to tell me, T3 by 4, okay, is equal to 2 times T half. Understood? This is for which type of reaction? For first order reaction. So why we can calculate T3 by 4 in a normal way. But if you know this relation, they will be giving you T half of a reaction is so and so. Calculate the T3 by 4 of that particular reaction. So in that case, if you know this reaction, we can easily substitute and do it. Otherwise, you need to do it and find it out. So a lot of time wastage will come. So that's the reason why it will be helpful for you. So I can say 2 into T half. Don't confuse it. 2 times T half. So this is the reaction you should remember. So this is for what sort of reaction? It is for a first order reaction. Okay. So next we will try to see the interval equation. I will explain what is interval equation. I hope this is very much clear for you. Any doubt, you please ask in the doubt clearance group. So next we will try to see the interval formula for a first order reaction. So before I say the term interval formula, I will explain you what is the circumstance which I am talking about. Let's say, for example, you have initially the reactant whose concentration is given as A. This is at time t is equal to 0. Okay. Now as the time progresses, now comes a new time, that is t is equal to 5th second or 5 seconds, after 5 seconds. Now we know that this A has decreased, and let me assume this is A minus x1 is what the amount of reactants that is remaining. Okay, here I am talking about the amount of product. Okay, amount of reactant, not the product, because for rate we always use reactant, correct? Amount of reactant. So at a time t is equal to 0, A is the initial concentration of the reactant. Now after time t is equal to 5 seconds, what is the amount of reactant? A has decreased and it has become A minus x1. So let us assume x1 is the amount of products formed, correct? Okay. Now after some another 5 seconds, let's say at t is equal to 10 seconds, I can say what is remaining is A minus x2. That means x2 will be what? The amount of product formed after 10 seconds. So what is the amount of reactant that is remaining? Initial minus the product x2, so that is A minus x2. Now in exam, suppose they are giving you this data, they are telling like a particular reactant gets getting converted to product. Maybe after 5 seconds the amount of reactant is A minus x1, and after another 5 seconds the amount of reactant is A minus x2. Calculate the rate constant. So in this case we just need to modify this formula. It is similar to our initial formula, that is 2.303 by T log initial concentration by final concentration. So that formula was for initial and final concentration, correct? Now we are talking about a time period in between. In that case we know that time will be what? That time interval in which they are asking you the rate. So this is now between 5 seconds and 10 seconds. That's why T2 minus T1. So let's say then this is my T2, this is T1 and this is T0. So I can say between this period means it should be final time minus initial time, that is T2 minus T1. Now log initial concentration. So in this period of time, what is the concentration initially, or in this period of time what is coming first? A minus x1. So I am substituting A minus x1. Now final concentration means after 10 seconds. What is that? A minus x2. That's why I am substituting A minus x2. Just a modification of that. Understood? This students needs to think and put it, but I am teaching you as such so that questions like this comes for the NEET, so that you can easily apply this equation and get the answer. Okay, so I hope you understood the scenario. Now let me tell what is this T2 and T1 in definition. So now I can say x1, where x1 and x2 where where x1 and x2 be the amount of reactant, be the amount of reactant, okay, be the amount of reactant consumed up to the time T1 and T2. Okay, so that is clear. Now okay, but here I should not say reactant, because otherwise students will feel x1 and x2 is the reactant. No, I can say where x1 and x2 is the amount of product formed. That is more correct. Product formed. It should be product formed up to the time T1 and T2. I can say A minus x1 and A minus x2 is the amount of reactant consumed up to the time T1 and T2. That is more meaningful. I hope now the interval formula is very much clear for you. Now we will go for the integrated rate equation for the nth order kinetics. I hope this much is clear for you. Okay, so next we are going to see the integrated rate equation for an nth order reaction. Usually up to in NEET up to now they have not asked beyond zeros and first order. So up to now they are always asking for zeroth order or first order reaction, but sometimes they can ask for second order and third order. So in the case of second order and third order only, please apply this equation. That's why I am here clearly saying n should not be equal to 1, or don't apply it for 0 also. It is always better to apply greater than 1. If it is a second order reaction, they are telling it very explicitly. So what you need to do, apply this equation, k into t is equal to 1 by, we know n is what actually, n represents the order, correct? So n is the order of the reaction. So since it is a second order reaction, I can say put 2 minus 1. 1 by A, you know, initial concentration, minus X. X is the, you know, amount of product formed. So A minus X is the amount of reactant remaining, correct? So here N is equal to what? If it is a second order, put 2 minus 1 minus 1 by A raised to N is equal to 2 minus 1. Or N, put for N 2. Then it becomes 2 minus 1. So this is the equation. Please remember kt is equal to 1 divided by n minus 1 in bracket 1 by a minus x whole power n minus 1 minus 1 by a n power n minus 1. Okay. Similarly, if you substitute here t half means what will happen to x? X becomes a by 2. So if you do that, you will finally get something like this. Either you can remember this, or you can substitute and get this. Okay, so t half for a second order or a third order, like that if they are asking, it means k into t half is equal to 1 by n minus 1, 2 power n minus 1 minus 1 divided by a power n minus 1. So here also this is also applicable for n greater than 1, that is for a second order reaction or for a third order reaction, you can make use of these equations. I hope both these generalized equations will be useful for JEE students very much, and for NEET students also. We don't know what is upcoming for the NEET 2021. So please learn this, very simple to remember. So we will start doing problems also. Okay. So I hope up to this it is very much clear for you. So if you have any doubt, feel free to contact me. Okay. Now let's start doing some of the important questions. Okay. Okay. So now we have a question in front of you. I hope everybody could see the question. Please go through it. 90% of a first order reaction was completed in 10 hours. This is the first information given. That means 90% of a first order. They have mentioned it very clearly. It's a first order reaction. Now they are asking, when will the 99.9% of the same reaction will get completed? So we know that 90% got completed in 10 hours, correct? So they are asking you, in 99.9% will get completed in how much time? Surely I can say it will be more than 10 hours, correct? Because 10 hours is minimum required for 90% of the reaction to get completed. So this is a fundamental logic that comes. Immediately look at the option, and if all the option are saying like 5 hours, 7 hours, 10 hours, then some other value, I can say that any value which is less than 10 or equal to 10 is not the answer. That itself is a clue you can get the answer. You don't want to do it itself. So always look at the options, answer options, because there will be some clue. This is to save the time, because all these are 1 minute you need to do it, right? So there will be something kept like this, so you can think and put the common sense and get the answer. Okay, so let's do this by our standard process. So we know that K for a first order reaction, K is equal to 2.303 by T log A by A minus X, correct? Now they are telling 90% of the first order reaction was completed, correct? So 90% completed means, what does that mean actually? I can say A, that is the initial concentration, was 100. Now after some time, X is equal to how much? 90, because 90% is got completed. So what is A minus X then? A minus X is the amount of reactant that is remaining. So 90% completed means 100 minus 90, only 10% is remaining. So I can say that is 100 minus 90, which is equal to 10, correct? Now the purpose of the first statement is to calculate the rate constant k, and they have told for this what is the time taken. So time taken is given as 10 hours, correct? So let us substitute that. So k is equal to 2.303 divided by time, that is 10 hours, log a, that is initial concentration is 100, a minus x we calculated as 10. So if you do this, k is equal to 2.303, this cancels off, log 10 is 1, so I will write here log 10 is equal to 1, okay. Now 2.303 divided by 10, so this is the rate constant, hour raised to minus 1, correct, since it is in hour. We know the units of rate constant. So k 2.303 by 10, hour raised to minus 1. Now we need to calculate in the same equation 99.9%. So how this will get modified? This you need to remember now. This k value you should remember now. Okay. Now we will use the same equation, but the condition is different. So here what is the condition now? I can remove this. I will only remember the k value. Okay, so k value here is 2.303 by 10. So I will put that here, 2.303 divided by 10 is equal to 2.303 by t. So what is this t? This is the time when will the 99.9% of the reaction complete. So this time is the time required for 99.9% to get completed. So we say log, what is the initial concentration again? It is 100. Now a minus x, how will you calculate this? 100 minus how much amount of product is now formed? 99.9%. So what is remaining? 100 minus 99.9, correct? So that is around 0.1. So a minus x is actually how much? 0.1 it will become, correct? Now if you do this, you know that this will get cancels off, and I can write, now I can remove this one. Okay, so I can say here 1 by 10 is equal to 1 by t, correct, log, this can be 1 by 10. So I will say 100 divided by 1 by 10. So 1 by 10 is how much? This 10 will come in the numerator. So I can write it as 1000. Okay. If it is log 1000 means how I can write? That is 10 cubed. Correct. So I can write it as 10 cubed. If it is 10 cubed, again how I can write? 1 by 10 is equal to 1 by t. I know 3 log 10. 3 log 10. We already know that log 10 is what actually? 1. So I can remove this and keep it here 1. So now tell me, so 3 by t is equal to 1 by 10. So that means t is equal to 30 hours. So that means for the completion of 99.9% of this first order reaction, the time taken will be how much? 30 hours. I hope it is clear for you. If you have any doubt, feel free to contact us. Thank you. So we have the next question in front of you. I hope everybody could see the question. Please go through the question. A first order reaction is 90% completed in 40 minutes. Okay. Calculate the half-life of the reaction. So again here it's a first order reaction. So we know our fundamental equation, T is equal to 2.303 by k, either you can write k here or t here, whatever be it, okay, log a by a minus x, correct? Now tell me, here it is first order, they are telling 90% is completed. So 90% is completed means 90% of the product is formed. So initial concentration A is how much? 100. Then X is 90% completed. So A minus X will be how much? 100 minus 90, that is 10. Correct? Now apply this here. So T is equal to 2.303 by K. log, what is a here, 100, and a minus x, if you see here, 10. And I know this is completed in how much time? 40 minutes. So I can substitute t here 40. It is in minutes. Now calculate this, as I know this is log 10. So log 10 is 1. So I can say k is how much? 2.303 by 40. Correct? So 2.303 by 40 will come into picture. Now the question is, they are asking you to calculate the half-life of the reaction. So we know that, okay, so what is the half-life of the reaction? For a first order reaction we already learned that. Can anybody tell? So T half of the reaction is 0.693 by K. So let me write that. Okay. So T half is equal to 0.693 by K. This equation is applicable for what sort of reaction? For a first order reaction. Now K value we have already calculated. So let's substitute here T half is equal to 0.693 by 2.303 divided by 40. So if you calculate this, you will get the value of T half. So on calculating this, I hope you will get a value around 12. T half is equal to 12.03 minute, I think. Yeah. So you will get a value 12.03 minute, since it is in minute. Okay. So how you calculate is very easy. Take the 40 upside. So 40 into 0.6, approximately how much it will come? 24. Correct? 40 into 0.6. So 24. Now by 2 approximately you take. So you can say that 24 by 2 is approximately 12. That is the easiest way. Don't want to do it also. You can do it in a mental way. Okay. So we will go to the next question. So we have a new question in front of you. In a second order reaction, both the reactants have equal initial concentration. The time taken for 60% completion of the reaction is given as 3000 seconds. What will be the time taken for 20% of the reaction to get completed? So this is the question here. So we have already learned whenever orders of 2 and 3 comes into picture actually. So what is the general equation you need to apply? So I hope you are remembering that. So I can say Kt is equal to 1 divided by n minus 1, correct? In bracket, what will come? 1 by a minus x whole power n minus 1 minus 1 by a power n minus 1. And I know that this is for second order, third order like reactions. Now in the question they have given it clearly, it is a second order reaction. So apply n is equal to 2. So what will happen? Kt is equal to 1 divided by 2 minus 1, that is 1 itself. Correct? Now here 1 divided by a minus x, correct? 2 minus 1, that is 1. So I can put 1 here. Minus 1 by power 2 minus 1, that is again 1. So this is the equation finally coming for a second order reaction. Now I can cross multiply this. On cross multiplying, what will happen? So I can say on cross multiplication the equation becomes, how the equation changes, let's do. So in denominator a into a minus x and in numerator a minus x, correct? So if you calculate this, you know that if you open the bracket, this becomes minus a and this becomes plus x, correct? And this will get cancels off. So finally I can say my equation is what actually? Kt is equal to x divided by a into a minus x. This is the equation. Now let's apply the condition and first calculate the rate constant K for this second order reaction. Okay. So let me do that. Okay. So here they are telling like the time taken for 60% completion of the reaction is 3000 seconds. So K into time is given as 3000. So 3000 divided by x. So let's say 60% of the reaction is completed. So let's assume initial concentration A was 1. Instead of 100 I am taking it as 1. So 60% completed means what actually? 60 by 100, that is 0.6 is completed. So that means amount of X formed is how much? 0.6. Now 60% is completed means what is remaining? A minus X will be how much? I can say 1 minus 0.6, that is 0.4 is remaining. So now I apply here X is what actually? 0.6 divided by A is 1 into A minus X is 0.4. Okay, K into T, X by A into A minus X, that is what I have applied. So I have assumed initial concentration is unity. So 60% completed means 60 by 100, that is 0.6 product is formed. So remaining amount of reactant is 1 minus 0.6, that is 0.4. Now let's calculate the rate constant K. So K is equal to, so we know that 0.6 by 0.4. So multiplying 10 with on both sides, this will become what actually? So I can take 3000 in the denominator. So 0.6 by 0.4 into 3000. So I am multiplying 10 on both sides. So this will become 6 by 4 into 3000. So do it. So I know that this is 2 times, this is 3 times. So this will get cancels with this one as 1000. So my K value is 1 divided by 2000. Please calculate and ensure that you are getting K value as 1 by 2000. So once you get the K value, we can apply in the second condition. Okay, that is they are asking you what will be the time taken for 20% of the reaction to complete. So let's apply that. So we know the K value as 1 by 2000. So let's see how it is. Okay, so again the same equation holds good. Kt is equal to X by A into A minus X. Now K value we have calculated, that is 1 by 2000 into T is equal to X. So this time they are telling 20% of the reaction is completed. So initial concentration was 1. So 20% completed means 20 by 100, 0.2. So I can say X is 0.2. So A is initially 1. Now tell me what is A minus X. A minus X is equal to 1 minus 0.2, that is 0.8. So let's apply that. X is 0.2 divided by A is 1. A minus X is 0.8. So let's calculate this. So T is equal to 2000, I am taking numerator. So 2000 into 0.2 by 0.8. So what will be the value? I know this is 2 by 8, multiplying 10 on both sides. So this will become 4. So 2000 by 4, I know the answer is 500 second. So this is the answer. So 500 second is the time taken for 20% of the reaction to get completed. This you can think logic. I told you, right? It will be less than 3000 because 3000 is the time for 60% of the reaction to complete. So 500 is the time taken for 20% of the reaction to complete. Okay.